Hello and welcome to my channel. Rhino here. Today, we're looking back in on our mechanic/chemist, John Morris Pendelton. When we last left him, he was about to get into the argument for a young Earth from the human population, which is quite possibly one of the silliest arguments that creationists have. I was just considering skipping it outright, but it might be entertaining, so let's just have a quick look-see.
Another clock that indicates a young Earth is the world's population. A few years ago, we passed above 6 billion people in the world.
And about 9 years ago now, we got to 7 billion. We're currently sitting at about 7.6 billion.
We want to make a calculation backwards to find out how much time will it take to have 6 billion people alive on the Earth.
What an odd way to phrase that. I think what you're trying to say is that you want to extrapolate the population growth rate into the past and see how long ago the population would have been down to 8 individuals if you assume a constant growth rate.
Again, I propose an average number of 150 years to duplicate the living population on the Earth.
Where did you get that number from? Doesn't really matter, because one of the first things that you find when you start looking into population doubling times is that there are what are called resistance factors that prevent the doubling from continuing unabated forever, which is linked to the carrying capacity, which is essentially the maximum number of organisms that can be handled by their environment at one time. If a population is under the carrying capacity, it will grow. If it is above it, it will shrink. This is the morbid equilibrium that I've referred to in other videos. If an organism reproduces beyond the carrying capacity, then there will be starvation and disease that bring that population back down under the capacity.
Again, I realize there's times it takes more time than that, times it's taken less time than that.
Okay, so it is a variable rate depending on the circumstances. Knowing this, why would we use it as a constant for any real calculation? And 150 years ago, the world population was between 1 and 2 billion. It didn't get to 3 billion until 1960. So we're supposed to trust your calculation when the first iteration can't even be close to correct?
But to get an idea. So we start out with 6 billion people, count back 150 years, and take half of that number, which is 3 billion. We add another 150 years and take half of the previous figure. Keep adding 150 and take a half.
We're going backwards, John. I think you want to subtract 150 years.
As we scroll down to the bottom of the page, we see that after 4,500 years, there would only be 5.5 people left.
You can't even get to the right answer with your method. It's supposed to be 8 people. And also, using these numbers, that means that Pharaoh Pepi I ruled over the 6th dynasty of Egypt with less than 10 people in it. Significantly less, given that these less than 10 people had to also be in Central America, Asia, Australia, Europe, and Africa, in addition to the Middle East. So your first iteration of this calculation is wrong, and your last iteration is wrong. What does that say about the middle?
Whoa. What happened 4,500 years ago? Well, according to the Bible, there was a worldwide flood that cleared the whole earth, and only 8 people survived.
Notice that 8 is not 5.5. To get from 5.5 to 8 people, you need a margin of error of 45%, if I calculated correctly. That seems a touch on the large side, if you ask me.
Just think, with 8 people and 4,500 years of time, we could have the Earth population today of over 6 billion people.
Well, considering the fact that the Earth's population remained under 1 billion for hundreds of thousands of years, I'd say this whole argument is a non-starter. We didn't get to 1 billion people until around the year 1800. Using your numbers, that means that we should get to 4 billion people around the year 2100. No matter what angle we look at this calculation from, the numbers don't end up matching reality, like not even a little bit. This should be the biggest reddest flag that you can imagine.
It agrees with what the Bible says, indicates a young Earth.
If you have to use such an obviously flawed formula that never produces data that matches with reality in order to get something that agrees with what the Bible says, then what does that say about what the Bible says?
But let's be generous. Let's say that the first human couple lived 45,000 years ago. 1 man, 1 woman, modern human beings. Year 0. 150 years go by, now we're 4. We go to 300 years, now we're 8. Follow out that calculation, how many would we be today?
There would be 4 times 10 to the 90th people today if we used that calculation, which is more people than there are atoms in the universe. Now, I know the easy rebuttal to this is the whole concept of carrying capacity, that there are only so many living humans that the Earth can support at any one time, regardless of how fast we reproduce. And to think that it would even be physically possible for the population to get to that point is just an astounding oversight on the creationist part. But let's just go for a different route. The unstated assumption here is that an organism will continue to reproduce without limit at the same growth rate. So let's look at seahorses. In some species of seahorse, the males will give birth to 2,000 babies, or fry, at a time. And yes, if you're not familiar with seahorse reproduction, I did say the males are the ones giving birth. The females deposit their eggs in the male's brooding pouch, and then the males give birth to them in a process that looks like sneezing, but instead of snot, it's children.
That is how a seahorse do.
An estimated 5 of these 2,000 seahorse fry can survive until adulthood. Now, on the long end of the scale, the male carries the eggs for about 45 days, and the male can mate immediately after giving birth. So in 45 days, we go from an initial population of 2 seahorses to a new population of 7 seahorses. This gives us a growth rate of 2.8% and a doubling time of 24.9 days. So after 4,000 years, you end up with 4.6 times 10 to the 48th seahorses. So not quite as many seahorses as atoms in the universe, but that's only 2 orders of magnitude away from equaling the number of atoms on the Earth total. But it's actually more problematic than that because when I first did this calculation, I forgot to convert my units. So as it turns out, that's actually only after 4,000 days, so only just under 11 years. So I plugged in the 1.46 million days that it would convert to, and the number was so big that I broke the calculator. I did plug in some dummy numbers just to verify that the calculator I was using could at least get to the number of atoms in the universe, and it can. So that's a lot of seahorses. And I didn't even get into the really fast reproducing organisms like bacteria, so yeah, it's almost like there are other factors that limit population growth than just how quickly they reproduce and how long they've been around.
Wow, we'd be standing chest against back, shoulder against shoulder, arms upon legs upon shoulders, miles up in the air covering the whole surface of the Earth.
No, with your numbers, we would have expanded to every corner of the universe and then some. But you see, the thing is, it's hard for people who haven't developed any space-related technology to reproduce out in space, seeing as how some 99% of the space in the universe is an almost certain death sentence for anyone that finds himself there unprotected. But sure, humans would have just kept doubling their population in spite of this.
We are not that many people. We do not find that many human artifacts, remains, or bones.
Same can be said of seahorses, which should have clogged the oceans a long time ago, according to your logic.
It indicates a young Earth, just like the Bible says.
No, it indicates that limited resources will place limits on population size and density, nothing more.
Now, some in my audience will be saying, fine, John, that's all well and good.
If anyone can come out the other side of that argument saying, fine, that's all well and good, then they were already on your side to begin with. It is a lousy argument.
But carbon-14 proves that everything is really, really old.
No, it doesn't. Though it certainly does demonstrate that there are a lot of things that are older than creationists think the universe is, which is more than a bit problematic for you guys.
First of all, how is carbon-14 made? Carbon-14 is made in that a cosmic ray hits nitrogen-14 and changes into carbon-14.
So far, so good.
Carbon is normally carbon-12. Carbon-14 is unstable. We call it radioactive, in that it's unstable and gives off an emission that eventually reverts back to nitrogen-14.
I'm impressed. That is actually a decent, if simplistic, explanation of the process.
Now, all living things are made up of carbon, and some is carbon-14. Clams, algae, fish, birds, trees, animals, humans, all have lots of carbon, and some is carbon-14. While these things are living, there's a balance. But when there's death, there's a loss of carbon-14.
Okay, that last bit was more than a touch awkward. When an organism is alive, it will absorb carbon-14 from its environment, and it will also expel carbon-14 from its body into its environment. This will cause it to roughly balance out. The ratio of carbon-14 to carbon-12 in a tree will be the same as the ratio of carbon-14 to carbon-12 in the atmosphere. Animals eat plants, or they eat animals that eat plants, and so this material is incorporated into their bodies, so the ratio in animals will, through similar metabolic processes, be the same as in plants and in the atmosphere, with a few well-documented exceptions, particularly for marine organisms. Terrestrial organisms get their carbon pretty much directly from the atmosphere, or indirectly through consuming an organism that does. Marine organisms, though, they get their carbon from the water, and the carbon content of the surface of the water is not the same as the deeper water, and as the deeper water mixes with the surface water, it skews the ratio to make marine samples look older than they are. Marine samples can be carbon dated, but you have to jump through a lot more hoops to do it than you would with a terrestrial organism.
The idea is if we could find out how much carbon-14 is left in something, we could know how long it's been dead. That's what the theory proposes. Now, they suppose lots of things, one of which, for example, is how much carbon-14 was there 2,000 years ago? We don't know. We weren't there.
We weren't, but plenty of trees were. We know that carbon-14 production in our atmosphere has not been a constant over time, so the different rate of production is something that has to be accounted for when doing the dating calculation. Using dendrochronology, we have been able to directly measure carbon-14 levels going back 14,000 years. Before that, we used things like atmospheric bubbles in ice cores for calibration, which, again, is a direct measurement of the atmosphere from the past. So, no, we don't just assume that carbon-14 levels have always been as they are today. We correct for different levels. In fact, the way we figured out this was a necessity was when we started carbon dating artifacts of known ages in the 1950s, and the dating results were several centuries too young. So, for older samples from human history, the carbon dates are, if uncorrected for, too young. And here stands John Morris Pendelton to tell us that all the dates that we have obtained from carbon dating are too old. I'd like to see the data he's working from.
What we do know is things that we know their age, carbon-14 fails to give the right age.
How much do you want to bet that he's going to use the carbon dating of marine organisms as his examples now? It's an easy enough thing to do. If you're a creationist and you're looking to have a sample dated, you just send the sample to a lab to get carbon dated. You don't tell them it's a marine sample, and they just use a regular calibration curve instead of any of the marine calibration curves, which are all different depending on the location, as they can be affected by several factors like water depth, latitude, shape of the coastline, wind, seafloor topography, local climate, and more.
For example, there was a seal that had been dead for 30 years when its carcass was tested with carbon-14, gave an age of death of 4,600 years. A seal recently killed gave an age of 1,300 years.
Yeah, seals. Marine organisms. Why the vast difference between the two? Well, they were probably from different locations, and as I mentioned, different marine locations require different calibration curves.
The bark from a living tree gave an age of 10,000 years.
Yeah, that claim gets repeated over and over again in the creationist publications, but while they usually do provide a citation for it, it's Bruno Huber's 1958 paper called Recording Gaseous Exchange Under Field Conditions, published in the Physiology of Forest Trees, I can't for the life of me find the actual paper. The paper has been cited a bunch of times, but the paper itself seems to have not been digitized. The papers that are citing that one seem mostly to be using a method developed by Bruno Huber for measuring CO2 concentrations with infrared light. In fact, going by the title of his paper, I'd say that it was published for the purpose of sharing a method of recording gas exchange under field conditions. This is pure speculation that I can't verify without seeing the paper, but I wouldn't be surprised to find out that the 10,000-year age for living tree bark was pointed out as being the result from an erroneous measurement using the method that preceded the one that he was developing. So, like, measuring this way, a tree that is known to be less than 10,000 years old is carbon dating at 10,000 years old, so that's why I developed this new, more accurate method. Again, just to reiterate, I cannot say for certain if that's what it is, but given the creationist penchant for ignoring 99% of a scientific publication to focus on the 1% that seems to agree with them if you remove the context, that wouldn't surprise me in the least.
It was alive. The shell from living snails gave an age of 27,000 years. Some of their membrane and tissue dated at 3,000 years.
The first thing you should know about this is that these are not terrestrial snails. They live in water. But it's not salt water, so the marine reservoir effect is not exactly applicable, but it is a similar idea. The springs that these snails live in are fed by groundwater that flows through channels of Paleozoic carbonate rock. Notice the word carbonate in carbonate rock. It's called that because it is rock that has a lot of carbon in it. The snails that live in these springs build their shells out of bicarbonate that is taken in through their environment. In this case, the water that is high in dissolved old carbon. They are literally building their shells out of carbon, meaning that the shells would carbon date older than the organisms are. As to the membrane from the same snails dating at 3,000 years, that appears to be a complete fabrication. The paper that dated the shell to an apparent age of 27,000 years made no mention of dating snail membranes at all, much less from the same snails that were dated to 27,000 years old. On top of that, this whole argument stems from a statement in the paper's abstract. If you read more than just the one sentence of the abstract that gives the date of the snail shell, you'll see that the paper is pointing out some of the known limitations of carbon dating using the snail as an example. In fact, you actually have to stop reading before you get to the end of the sentence that gives the snail's date, because right after it tells how old it dated the snails, it tells you why the dates are so off. They are attributed to a fixation of dissolved HCO3, which is bicarbonate, with which the shells are in carbon isotope equilibrium. Simplified, the bicarbonate is dissolved from old rocks, meaning that the carbon contained within it is old, so will provide old carbon dates. The snails are in isotopic equilibrium with them, meaning they get their proportion of carbon-14 from the bicarbonate rather than from the atmosphere, so their shells will date old just like the bicarbonate. This is the kind of creationist shenanigans I was referring to when I mentioned that they ignored 99% of a publication in order to focus on the 1% that appears to agree with them. In fact, that pretty much tracks here. By word count, the first half of that sentence is about 1.3% of the total number of words, so there you go.
From the other extreme, we have coal from Russia that's supposedly 300 million years old, gave an age of 1,680 years.
I can't find the exact source for this, but it doesn't matter, because the presence of carbon-14 in fossil fuels is well documented. In fact, it is important to find fossil fuels with low amounts of carbon-14 for use in neutrino detectors, so there has actually been quite a bit of work done to figure out how to determine which fossil fuels will have lower amounts of carbon-14. When the C14 decays, it can light up the scintillation fluid, which is the fluid used in the detector. In this case, the fluid has a base of methane or oil. When it lights up because of C14 decay, it gives a false reading. So when studying various fossil fuels to figure out how to predict which ones will have high C14 concentrations and which ones will have low ones, it was found to vary wildly between locations. But these variations correlate pretty closely with variations in uranium-thorium content. Why is that important? Well, remember earlier in the video when John explains that C14 in the atmosphere is produced by nitrogen interacting with cosmic rays? Uranium decay produces the same type of radiation that produces C14 from nitrogen. And since there would have been C14 in the coal at the beginning of its life, there is now nitrogen in it that can interact with radiation from uranium decay to become C14 once more.
Carbon-14 is not reliable for dating things that used to live.
No, it is quite reliable when used correctly and accounting for the variables that we know can affect the results. And to think that you can disprove it by pulling examples out of studies while ignoring the rest of the study that your example came from is just plain ignorant. Will John figure out a dating method to show a young Earth that isn't ridiculous on its face? Will he manage to disprove more than a century of science supporting radiometric dating methods? To find out, tune in tomorrow. Same Rhino time, same Rhino channel.